Hi everybody and welcome to Undenominated Science. Today I'm going to talk to you about how you can study physics or end up with a physics degree here at the University of Galway through GY301 or Undenominated Science. So the first thing is that we are here in the College of Science and Engineering, and physics lives within one of the 5 schools within this college. So lives within the School of Natural Sciences. So within this school, there's also Earth and Life Sciences, which comprises botany, zoology, and earth and ocean science. And then also there's the discipline of physics. So you don't need to have studied physics for your Leaving Cert in order to pursue physics with us here as part of your science degree, or even if you wanted to specialise in physics down the line. But for those of you that haven't studied physics, physics is a fundamental study of nature, which we use the language of mathematics and experimental studies in order to make sense and describe the world around us. When we study physics, we study very large objects on the planetary scale, right down to very small subatomic scale particles. And physics deals with the interaction between energy and matter, the two fundamental ingredients in the universe. So as part of your first year physics course, you'll get a wide exposure to all the different topics of physics, including classical physics and also modern physics, which comprises relativity and quantum physics. So as you pursue your study of physics, you gain skills such as numerical skills, data analysis skills, experimental and laboratory skills, and problem solving skills. And this renders physics graduates very highly employable across a wide range of different environments. So often physicists would work in development of new technologies, in the finance industry, working in the construction or energy sectors, working in culture, working in healthcare, or solving societal challenges such as climate change or food security. So these are just examples of the type of environments that people that have studied physics will find a use for their skills, for their skill sets. Within physics in the University of Galway, we have a number of research centres that nurture talent in order to develop new technologies and new knowledge to solve societal challenges. So, for example, in the National Centre for Laser Applications, or the NCLA, we apply the state of the art in terms of laser technology in order to develop new instruments, new technology, and new medical devices to solve the challenges of today and the future. The Centre for Climate and Air Pollution Studies has been monitoring the state of the atmosphere for decades. So this research cluster of atmospheric physics has been working in Galway since the 1950s, monitoring the changes that are occurring in our atmosphere, measuring how dirty is the cleanest air within Europe, with our sampling site that is on the edge of the Atlantic in Connemara. So the knowledge that is generated in this centre, it sheds a light on how fast our climate is changing and what impact this has on both our climate, on our air quality and our health. Physics is also home to the Centre for Astronomy, from which we run the Physics and Astrophysics degree programme stream. And we also carry out research in astronomy and astro-instrumentation and computational astrophysics. The research topics covered in this centre include stars and planets, their formation, magnetic fields, end stages of evolution, astronomical instruments and gamma ray astronomy, as well as extrasolar planets and circumstellar disks. So the astronomers in the Centre for Astronomy have access to telescopes all over the world, which our students use then for their own research. We also have the Applied Optics Group, which work on optical instruments applied to both astronomy and also to healthcare. And speaking of healthcare and medical physics, the example of 2 other groups, the TOMI and STARSEM research groups, which work on imaging, on drug delivery, and also on regenerative medicine. So you can see how the different research groups in physics can be applied to solve societal challenges in terms of health, in terms of climate change, in terms of technology. So all the time we're applying knowledge of physics in order to solve problems for society. So your journey in physics starts here with PH 101. So that is the fundamental first year physics course. Some of you will only study physics with us for 1 year and then you'll continue on with the rest of your degree, whereas others may choose to continue with physics, whereby you could emerge in 4 years with a degree in either physics and climate physics or else physics and applied physics. And as you progress through your degree, the modules that you choose will determine your pathway and determine your specialised degree, what you'll come out with at the end of year 4. So if you're interested in physics and climate physics, this is what your modules will look like as you progress from year 1 through to year 4. The most important thing here is if you want to study physics and climate physics, which still give you all the employability options of a physics degree, but just viewed through a climate lens, you must study chemistry in first year. So along with physics. So in first year, you must take PH 101 as well as Chemistry 101. So then, as you progress through the years, you will see there are core subjects in second year: computational physics, energy, forces and motion, thermodynamics, modern and electricity and magnetism. But then you will also have specific electives that are particular to the stream that you chose. So for physics and climate physics, you must do chemistry in first year, and in second year you do either chemistry or earth and ocean science. And there are some other interdisciplinary modules that you would take. In third year then, you would study physics of the environment and mathematical methods. But the important thing is, if you're interested or think you may be interested in pursuing physics and climate physics, you must take chemistry in first year. Always you can converse with your lecturers and with myself as the GY301 physics representative if you have any questions about these streams. If you think you would like to study physics and applied physics through undenominated science, well then there's no need for you to take chemistry. You must take physics, PH 101 in first year, and then you'll pursue with the core physics modules in year 2 and year 3, and you will emerge in year 4 with a physics and applied physics degree. So just to recap, if you're interested in physics and climate physics, be sure that you take chemistry in first year. But if you want to take physics and applied physics, that is a subset of the physics and climate physics degree. All you need is physics in first year. However, there is one requirement, and that is the mathematical requirement, the maths requirement to pursue physics. So you'll recall earlier on I said that in the discipline of physics, we use the language of maths to make sense of the world around us. So that means you must have a high level of mathematical skills in order to pursue physics. So if you're interested in studying physics, you must take, alongside your core physics module, one of the following options, one of the following mathematical pathways to pursue physics. So you can either take the physics pathway along with the applied maths pathway, where you will take MP 231, 232, 236 and 237 in second year, or else the mathematics pathway, or else the mathematical studies and computing pathway, or the applied mathematics electives. Now the fourth option here can be done in second or third year, but the rest of the other pathways are taken in second year. So if you want to pursue physics, you must take one of these combinations of maths modules, otherwise you won't be able to graduate with a physics degree. Again, you can always come and talk to me or talk to any of your lecturers regarding your module options. So your 2 points of contact throughout your first year physics. My name is Liz Coleman, so I am the GY301 physics representative. So if you have any questions, you can always get in touch with me. It's liz.coleman@universityofgalway.ie, or Mark Lang, who is the first year coordinator. There's also additional supports that are available to you as first year physics students. There's the problem solving sessions, or PUPs, which are specific to physics, so you'll get help with physics concepts or physics problems. And then there's the CAME, shared learning experience, and I urge you to make use of every support that is available to you in first year. So thank you very much for listening. Please do get in touch if there is anything that we can help you with, and best of luck as you continue on your journey on GY301.